it is minus 4x squared plus 20.
I do not have the correct answer, but yeah, she sort of, um, yeah, she kind of pointed out that that one part was incorrect. The
I think
minus
she's pointing out the
plus.
sign though. For sure the
Yeah,
sign. It should be a plus. Now, if it's truly the last thing, it is the way I'm showing it here. It's 4 f of x,
got it.
but it's out of order. So that's also kind of a challenging thing to go through.
Yeah, and then kind of same thing as number 3 for number 8. You have to factor out the coefficient, and I
Yes.
put the right 6 as the literal -6 that was there instead of factoring it out, which would have gotten 3. That's the correct right 6. But then on the back of the second page of the PDF, the number 11. The graph that's right there is the one that I did for the corrections graph, like what she put as the
Yeah.
correct answer. When I did it, I kind of got confused because I got like a graph that went up and then down and up and then down, and it didn't quite look correct. So I decided to come back to that, but it didn't. Um, and then yeah, so the table that I got is there, but she got for the piecewise function, x is greater than 1, x is less than or equal to 1. And that would have changed the increasing, decreasing. So,
Right. There's a pattern here that you didn't factor out the 3 inside the absolute value. Like that's really important to do there for number 11.
yeah,
And so without that, you're really in a bad spot here. Like you really needed to go 3x minus 1. And then like we had done before, you take the absolute value of 3, absolute value of x minus 1. So we did problems like this. Maybe we just didn't do enough of them. I'm not sure. Um,
yeah, I'm trying to make a pattern where like it's probably some of these like maybe I don't know, like maybe we had not practiced, but like on I should practice a little bit more of it. So maybe more practice would probably help as well. Also, yeah, so so when it came to the plaque, I wasn't necessarily rushing for the exception of number 14. I think that was more institutional, but number 12 was so there because it was 1/2 here, but I wrote it as -1/2. So then from there I used the -1/2, and that kind of made the everything else
Mistakes from the beginning, you can't correct. It's hard to
yeah,
fix. Just really hard to fix.
yeah. And then
I
for
do I do notice, and I'll just point this out here for number 11 again, that I had really emphasized not using fractional points, avoiding those at all possible, and that didn't
yeah,
happen
that
here.
kind of confused me as well because when I was plugging in like I put the vertex in the middle and then 2 below, 2 above, and when I plugged in 2, I got negative 12 halves or 13 halves, sorry. Um, I got like a decimal and when I converted it to a fraction, it was -13 half. So that was a bit confusing, which is what made the graph a little bit weird. So yeah, that kind of not factoring it out kind of like messed up with the graph, which then in turn also like the piecewise function kind of trickled down to the increasing and decreasing. Um, and then for number 13, like the one in pencil in the graph there is one that I put in the bigger one there is the correct graph.
Mhm.
Um, So I got -2, -3 for the vertex. So apparently the correct answer was -2, comma 3. So we can go over that question.
Yeah, let me snip that in here. We'll look at it. Um, there is also like, let me say it's like there is another way to do this, but you did it the way where A is -3, B is -12, and C is -9, and X equals -B over 2A, which is minus a -12 over 2 times -3. 12 over -6 equals -2, just like you had there. Then we talked about this idea that you really want to show the variable as being in parentheses. Like eventually you won't do this, but for now it's good to do. That way you don't miss signs, which is probably all that happened. I noticed this in your first quiz that your teacher chose problems where you could easily make sign errors and wouldn't know it. So this is 4 times -3 minus 12 plus 24 minus 9, which ends up being positive 3. I don't see any work. I guess you completed the square to do that.
Yeah,
So
that's
you kind of mixed. It's like if you're going to use formulas, I call this using formulas, then you'd use formulas. If you're going to complete the square, then you complete the square. Like you just go one way or the other. I would not have completed the square on this one, although you could.
got it. Yeah, yeah, because I could see how I did the x equals -b over 2a, and also kind of completed the square in the bottom. Um, yeah, I got that, but then okay, so yeah, I think when I was completing the square, I made a mistake of um, um it would be minus 3. We should make the vertex 30 plus 3, which means the vertex -2, 3. Yeah, I got how they got -2, 3 now, and the graph as well. Um, so then for number 14, that was most because by that point it got very close to the end of the period. So that was a lot of rushing. I tried to do the completing the square on the bottom there. But then I ended up with like a square root of a fraction, like yeah, calculation error.
Yeah, so
Um,
in fairness to you, we never did a problem like this. Like
yeah, but yeah,
this is totally unknown. Now, this is in factored form, and what I mean by that is you set each of the factors equal to 0. And so these are your two zeros of the graph. Now the vertex is always right in the middle.
so in this case, it would be like, if it's in the
5 over
middle, then
2.
wouldn't it be 5?
5 over
But
2 or 2.5.
how would you
Now,
get
I
5
never
over?
told you that. I never told you this. This like that's not you, I mean, you might have figured it out eventually. I mean, you would have, but I never said that this was. So 2.5, 5 over 2 is right in the middle. That's one way to do it. If you're going to complete the square, because you need that number right in the middle of the table. Like you're making a table here,
Yeah, I think that kind
you
of for the table, which makes
and
sense,
that's,
right?
but you still don't have the Y value. You can get the Y value by putting that back in. I don't know if that's the best way to do it. The other way to do it here is kind of what you were trying to do here, but completing the square is hard in this one. It's 3/4 x squared minus 5x in parentheses. And then what you have to do here is you have to almost like slide this over and say, okay, it's x minus 5 over 2 squared. This is 25 over 4. You can see where we're going on this. All right. And then there's actually like a previous line here, which we don't have, where it's 3/4 x squared minus 15 over 4x plus 75 over 16. And then that's what would go to the other side of the equation. And then you'd move it
God,
back. And that is your vertex. Now, I don't know, did you go through this in class? Because it's almost like they could have just said, hey, here's the two intercepts. Like, what did they do in class? Did they
yeah.
make a table? Did they?
In class for this type of problem, yeah, let me look back at the no. Here.
So I guess this is where you got to kind of pay attention to the way, and we didn't do any problems like this in review. So, um, this is kind of
Uh,
thing where if this is the only one you got wrong, I would be like, okay, we're doing a good job. But because of some of the
yeah,
other problems, we just didn't do enough practice, or you maybe on your own, you didn't have practice the ones that you had questions about, and maybe mixing, you know, like it's like there's a bunch of stuff you do when it's in standard form. There's a bunch of stuff you do when it's in vertex form. Like you gotta kind of know how to navigate these paths. That's what the whole
yeah,
test quiz is
I
about.
think more practice would have probably helped for
Yeah.
a lot of the easier questions on the front. I mean, on the back, maybe like looking at other problems out of like the ordinary what she gave, maybe like because this right now we're just looking at 2.4. We did problems very I can't see one where it's the fraction x and then x minus the like a number, but there is like there is like the fraction with the in factor. We did do factors form, but we didn't. I don't think we did anything quite like that. I mean, we might have done it in um somewhere in 2.2 or 2.3. Um, but
These
I think
problems are substantially more, it's not difficult, but because you're mixing them all together, they're more, you got to transition very quickly between each type, whether you're in
yeah,
standard or so one of the things you could have done is mapped out this quiz doing all the standard form stuff first or all the vertex form stuff. Like you might have, and I know you just do them in order, but
yeah,
that's
yeah, yeah. I think working on timing also um because sometimes if I like for example for some of the ones on the front of the test. Like for some of the ones that I was kind of still not sure about, I was kind of still trying to work it out. So maybe like skipping it and coming back to it. The only thing is that last time, luckily I didn't leave it unanswered, but there was one question I believe on the chapter one test that I didn't know, but I decided that I wanted to come back to it, but I didn't. But I did end up like last minute circling like the answer that I thought it was like the best guess of the answer. But yeah, so maybe more practice is probably better for these. Anyways, we do have a chapter two test next week, which the stuff will be that all of the things on this quiz will be on that test. So this might be a really good study material for that test because he will probably give problems very similar to this to test this like few lessons of the chapter then.
yeah. So
Um,
if you need me to, I'm happy to give you problems like any of the ones here that if you want us to
yeah.
do. You just have to tell me, "Hey, these are easy to make up and be similar to." So what would you like to do? What would you like to do next?
Um, I think we'll do some practice with factoring out the coefficient, for example, like Maybe questions like number 11, maybe.
Okay, sounds good. Right, so let's do one like 11 here. Let's say g of x equals 1/3. Uh, yeah, we'll do that. Absolute value 2x minus 4 minus 1. All right, so I want you to first determine the vertex here by, like we talked about, factoring out inside the absolute value, kind of rewriting this as much as you can.
All right. So 20. I got 2 comma negative 1 because at first I didn't factor out the 2, so yeah, then
Yeah,
I
so
have
this
2.
becomes 2/3 absolute value x minus 2 minus 1, like that. So this is where, we've
Oh,
talked about this.
wait, wait, wouldn't it be 1/3 absolute value 2 times in parentheses x minus 2? Then
Yes, yes, but, right? What is the absolute value of 2?
that would be two, oh, something gets so it's simplified down from
Yes, yes.
that.
It's good that we're talking about this because that is something you would absolutely need to be able to do here. All right, so this is where we're going to run into problems because if you're graphing this, which is what 2, -1, that's great. Okay. Now, let's just say you put 1 in for this thing. You're going to get a fraction. And this was my concern. This is one of the things I wish was made a bigger emphasis in the classroom. You really don't want fractions here. And the way you avoid fractions is having the number inside the absolute value be a multiple of 3, right? So let me give you a multiple of 3 here that works. 5. Okay. So 2/3 absolute value 5 minus 2. 5 minus 2 is 3. You kind of have to look ahead. Okay. 5 minus 2 is 3. Absolute value is 3. 2/3 of 3 is
Thirds, which would be
2 because the 3's
yeah, 2,
canceled.
yeah.
2 minus 1 is 1. Okay. Now, by symmetry, you went 3 this direction.
So 3 opposite direction be minus 3, so it's minus
Right.
1. and it'd be the same as 5 because
And so you'd go another three. So I want you to put eight into this right here.
3 into. All right, that would be 3.
Yes. And then if you go the other direction, -4, it should also
That'd be
be 3.
3.
And these are nice numbers to graph.
Got it. So it isn't always just one down.
No, and it shouldn't be because that, I mean, maybe you're a computer, but not as a human. It's hard to do one away. You want to have nice whole numbers on your graph. Also makes it easier to
Got
grade
it.
for them. I don't be figuring out is it 1/3 or is it 2/3, things like that.
Got it.
Now let's talk about the piecewise function part. So that's coming up here. Okay. So the first thing is you got to figure out the breakpoint. The breakpoint is the x coordinate of the vertex. And we always did one or the other, or right greater than and then less than.
Mm, oh, uh, complication. Wait, wouldn't you have to put greater than or equal to or less than or equal to
Sure. And this is
for one
where,
of the
yeah, you have to pick one of them and it doesn't matter, but you go with the one that your instructor does.
uh, would it be 3/2 for the first equation, 3/2 parentheses x minus 2 minus 1?
2/3, 2/3. You said
Oh,
three
yeah.
halves.
Oh,
Yeah, and this is fine for me. Now it looked like you simplified it. I don't know if you did or didn't, but
no, I just transferred the capsule value into
okay.
this thing. So, all right. And then for the second one, x is less than or equal to 2. Um, that would be negative 2/3 x minus 2 plus 1.
Great.
And then it would be x is less than or equal to. So you have to have it on.
And you can simplify if you want, if you think that that's what the instructor wants. Um, the increasing, decreasing, you don't have to simplify. It comes from the stuff on the right here. It might be good to make a quick sketch of it, like we talked about. Even if it's just a tiny little thing, it's like V or V, which one is it? And that way
Got it. Just to have a basic understanding of which way the graph is going.
right, right. Or, tracing it with your finger in the air. That's also good.
Got it. So then for this one, so this one, the increasing would be 2 comma infinity,
Good.
and the decreasing would be negative infinity comma 2.
Yeah.
And then, yeah. And then the domain would be negative infinity, comma, and the range, -1, including comma infinity. Right, so with the, yeah, the -1.
That's everything for this one.
Uh, and
That-
yeah, it might be helpful to go through an example like number 14.
okay. Yeah, very, really kind of similar to what we just did here. So let's see, we just did that. Let's go. Yeah, let's do 1/2. Let's do j of x equals 1/2 f x plus 3, like that. So
Right.
there's, I showed you two ways to do this problem. Like you either figure out where the vertex is by using the factors, the zeros, or you complete the square. What do you think you would do here?
Uh, so wait, for the zeros, um, you, so wouldn't the x value for the vertex still be 3?
Nope. Just the factors are where it crosses the x-axis.
Uh, yeah, then this, oh yeah, now I see it. Yeah, then it'd be x equals 0, first x, and then x plus 3, which is the second x, which should equal x minus 3.
So now, like I said before, your vertex is always right in between. If that's 0 and that's negative, through the x coordinate of the vertex is always right in the middle. Okay. So to get the y coordinate of the vertex, you could complete the square, but you don't have to. You just put this back in.
You plug it in.
Yeah. So why don't you do that for us, please?
Uh, like this. Got 3. I got j of x equals, or the y value would be 3, which means the vertex would be -3/2, comma 3.
You're a little off on that. Let's look at it. -3/2. You're multiplying. -3/2 plus 3. So the one on the outside here is -3/4 because you're multiplying. The inside here, it's 3/1, so we'll make it a common denominator, 6/2, which ends up being -3/2, or sorry, +3/2 when you add like this. So it ends up being -9/4. over 8 like that. Just double check. Not sure.
Let me see where. Wait, wouldn't it be -4 over 2 instead of -3 over
Are you talking about when you add inside here, or where are you
when
referring?
you multiply 1/2 times -3 half?
You multiply the top, multiply the bottoms.
Yeah. Uh, so then yeah, it'd be 3. Yeah, then I got -3 for it. Yeah, so I
Okay.
think that, yeah.
So this doesn't help you a ton because when you're graphing this thing, and I don't think the graph was super critical, but -3/2, -9/8, and then it's if we go back to what the original one here is, oops, let me see if I can grab it. Copy. Okay. So yeah, like this is bad because the fraction is tough to graph. So what I would do is try to pick whole numbers that are a certain distance away from this. Like let's just say you pick -1. I don't love it, but we'll go with -1. So j of -1 is 1/2 times -1 times -1 plus 3, which is -1/2. -1 plus 3 is 2, ends up being -1. That's a good point. So it's like, well, how far away is it? Well, it's a half away. It's half away, so we're going to go half the other direction, which is -2, and that should also give you -1.
Got it.
Now, if you go a half this way, then you got a fraction here. So let's not go a half. Let's go a full. Let's go to -2. It's plus a half plus a half. Like basically you're trying to, or sorry, not -2, 0. Go the wrong direction, 0.
Got it. So in this case, you're going up by half.
Well, if I go up by half, it'd be -1/2. And I don't like introducing more fractions into this, so I'm gonna not do that one and go to 0. But it may or may not work. So j of 0 is 1/2 0 times 0 plus 3. What is 0 times anything? It is 0, so it does work. And we shouldn't be surprised because that's a 0. And so now you have nice points. Most of them are nice that you can graph.
Got it. Yes, so this time you don't get like wait, but wouldn't you still get a fraction when you go to -3 half, or you get when you go to from -2 to -3 halves?
No, because you're going 1/2 this way, 1/2 the other way.
Got it. Yeah.
And then from -1 to 0 is really +1. So now if we go -1, we get to -3. You've got to go the same offset. Um, all right. Um,
Maybe we'll actually,
So what I was going to suggest here is that you um, maybe rework these problems, trying your best to cover up the solutions, meaning the ones on your quiz, any of the ones we've done
yeah,
today, previous ones. Um, Not right now, just maybe take a break and then come
yeah,
back. Uh, and that's going to be really key for you. And only the ones you got wrong. You don't need to practice the ones you got right. Like that's ridiculous. Just the ones you got. So, um, all right, we got another lesson on Thursday. So we'll pick up here, but you probably have new stuff for us to think about. So go ahead and